Today we'll be talking about memory management. So memory and management. What have you heard about memory? What have you heard about management? Why do we need management of memory? Let's start with memory. Memory is otherwise known as your RAM. And nowadays we have a lot and a lot of RAM. And by a lot I mean this laptop right here. It's about 6 years old and it has 16 gigabytes of RAM. And 16 gigabytes is a lot of storage. You might think it's very little cause right now the technology has been evolving so much, but it's a lot of bytes. 16 gigabytes is 16 times 10 to the power 9 bytes. That's 16 billion bytes. So imagine a list of 16 billion numbers. That is what your computer has to manage every single moment. So how do you manage this massive list of numbers? Let's imagine the RAM as this long list. I'll just put it as a rectangle for now. That's not a rectangle. But imagine it's this very long list. Whatever. And it's split into different locations, and each location you can put one item. So there's location 0, 1, 2, 3, 4, etc. all the way to 16 billion. So in position 0, I can put, let's say, the number 16, and I can put numbers, random characters, random strings, etc. But watch what happens when we have to store larger items. If we want to store an item that takes this much space, we can't really split it into these spaces, as of now. So one approach we're going to take is called the fixed partition approach. And the fixed partition approach works by splitting your memory into multiple fixed partitions, each of which is large enough to contain the largest object you need. So in this case, let's draw another rectangle. Perfect. Let's say this is the largest size we need. So all we need is partitions of this size, and we split the memory into sizes that are matching this size, and now we can put the items in as needed. So this fits perfectly in here. Nice. We can now store the object in memory. However, what happens if we have very small objects? Let's say I have a very small object like this, and I have like 5 of them. I'm gonna put it here, I'm gonna put it here, I'm gonna put another one here, I put a 4th one here. Oops, where do I put the 5th one? So here comes the issue. Even though we have a lot of space in these places, we still can't fit any new information because we can only assign the data into the partitions we've created. Thus, this case where there's enough space but you can't use it is called fragmentation. And in our case here, this is known as internal fragmentation because it's inside the partitions that we've allocated. Thus, internal fragmentation is when you have space that's left over inside the partition. Thus, you cannot use it and it's wasted space, otherwise known as fragmentation. Well, how about we just make the partitions as big as the chunk we need? That's called dynamic partitioning, and that solves the issue of internal fragmentation completely because there's no additional space to be had. So dynamic partitioning, we get another rectangle here as such, and we just add items and partitions as we need. So let's say we add the first biggest partition, then we add 5 of the really small partitions, just like this, yada yada yada, and perfect. We have this much space, we can add as many more items as we want that can fit. Sounds perfect, right? Not really. Let's say we wanted to make this item larger. We can't really expand it because there's no space like around it compared to above where there's so much space to expand. So what you would have to do is copy the item over to a free space like here, expand it a bit, and then delete this space. Now you have a free space here. Let's say this is free. And thus you have to copy the memory every time you want to make it bigger, unless it's at the most corner slot here, which is unlikely. So that brings the issue of very slow memory. And that's important because memory is supposed to be fast. Every single operation on your computer depends on the variables in your memory. Another issue is, let's say we keep filling up this data with small, large pieces, etc., just randomly assigning for now. And let's say after some time we free some of the memory here in the middle. Oops. Let's say we just free some of the memory in the middle like this, like here, etc. So we have some free spaces, but not a lot. And now let's say we want to put something of moderate size, let's say this small, inside. Unfortunately, there's not enough free space at the end, but if you add up the free spaces that are here, they have enough space to store this. So again, this is a form of fragmentation, but this time the unused space is outside an allocated partition. It's the space between the partitions that are way too small to be used individually, but grouped together they can be used. This is called external fragmentation. So as you can see, there's a balance you have to maintain. If you strictly follow your dynamic partitioning, you end up with a lot of small gaps in your memory when they are eventually freed. And so that leads to external fragmentation. However, if you just stick to fixed large partitions, then you have suffer from a lot of internal fragmentation, which is an issue of its own. How do we solve these issues? Well, the main solution is to not have contiguous memory allocations. That's an extension of the fixed partitioning scheme where we split it into many small parts, and then for each of our processes we split it into many small parts as well, and then we just slot it into memory as much as we can. This fixes the internal fragmentation issue while also making things small enough such that we can fit things into the gaps that are left behind. This scheme is known as paging, but we won't cover it today since there's not enough time for that. So hopefully today you've gleaned some information on why we need memory management and two different ways of contiguous memory management, which is fixed partitioning and dynamic partitioning. And finally, we covered a solution to both problems, which is using the paging scheme.